So most of you have taken the exam at this point. A lot of people haven't, either because they are sick, they've said they were sick, or in the case of a few people, they didn't realize that there was an exam and they weren't attending their labs, which is very problematic. You're expected to go to your labs and come to your lectures. I don't take attendance for a reason, and this applies to none of you. If it sounds like I'm annoyed, this applies to none of you. You're the one showing up. You're doing great. If you're watching this recording and you're not regularly coming to lectures, you really should. That way you can participate and I can help you through these things. It's a much more valuable experience, especially since today we're going to plan on going over Lab 6 and doing some of it in class to help you out. Okay? Now, we're going in more detail about functions and returning in this week's playlist, as well as how to break things into functions. While loops are the other big thing that we do for this homework assignment specifically. And that's what I'll be going over today. Now, with regards to the exams, people just finished them yesterday. I haven't gotten them. The plan is that the TAs and I are going to meet over Zoom on Friday. I will give them the directions on how to grade it. Each will grade their individual sections. They'll hand back the exams in the labs after spring break. And then any issues with the exam that you find, come to me for corrections. In general, I tell the TAs to grade more harshly than when in doubt, as to be harsh or generous. Like, okay, this is like if it's a 7-point question, and I think it's half right. Should I give it a 3 or 4? I say give it a 3, because it's always easier for me to give points back if the students can explain their answer as to why they are justified for more points. Otherwise, though, for a student who doesn't really understand it and got lucky, I can't go back and take points away. That seems really not great, right? So if you do get a low score, here's a couple things. First off, if you're pretty sure you did well, it could just simply be an addition error. We've had addition errors that were up to 15 points off before. It happens. You forget to hit the wrong. You're adding up buttons on the calculator. It happens, Or in the case of just entering in grades into a spreadsheet, we could put, if you got a 85, oops, I hit the 7 instead of the 8, and I'm just going fast. And the next paper also has a 70, so I misread that. Oops. So that happens. It doesn't happen often, but it happens occasionally. So, the second thing is, again, you'll want to check what you did wrong. Hopefully the exam wasn't too bad. No? Yes? The next exam, no idea. Obviously, it's going to be sometime after spring break. But the next target for the exam would be, the next exam will cover file reading, dictionaries, and Monte Carlo approximations. However, the material is cumulative because you gotta you gotta know how to write for loops and stuff. There will be less of a focus on turtles on that exam, more of a focus on files. So I will adjust the due dates appropriately, but the next big assignment, after we do this assignment over here. Sorry, I just have to cover a lot of administrative stuff today. After this assignment, the file reading, okay, you'll be doing, you'll have the hurricane tracker assignment for once we get back from break. Okay, that's actually probably going to be introduced in your lab today. Okay, but obviously, not lab today, but lab on Friday and when you get back on Monday. There's big verbiage over here that I'll go over when we get back about making sure, just basically don't pull the files out of, all this is saying is don't pull the files out of the folder that you unzip it, right, from. So here I'm giving you a zip file, you download it, you put it where you want to work on it, and you unzip it, because there's a ton of files in this one. And what this is that it's kind of the culmination of what we've been doing in class. You write a program that does this, that given the path of a hurricane, given the locations of a hurricane and its intensity, you plot its course. This was Hurricane Irma. So it is, now it looks very, very hard, right? Or it looks very advanced. It took me about 3 hours to program and most of that time was because I made a mistake, trying to figure out a single mistake where I flipped longitude and latitude. Okay? So anyway, so now that I'm announcing that in class, hopefully you can learn from my mistake that when you're working on this one, and I'll mention this multiple times, if you're trying to run this and your hurricane does not appear, you may have just flipped longitude and latitude. Interestingly enough, this is actually all done in Turtle. This is all done with Turtle graphics. And we give you most of it. The Turtle is given the proper symbol. We give you the background. The background's already generated for you. It's just a matter of moving the Turtle into the right direction. And where's that based off? It's based off the file. But we're not even there yet. Okay? We've got Lab 6 that we're going to cover, which is due Friday, so we're going to do a lot of it in class today. Okay? The other thing is that midterm early alerts are coming. Midterm early alerts are. I need to do those soon. Okay, that's where you get a satisfactory or unsatisfactory report, right? You probably had that last semester. Everybody remember those, right? These have no bearing whatsoever on your actual final grade or on your GPA. They're literally just simply to alert students that, hey, you may be falling behind. As a result, I tend to be very aggressive with them. So if I feel like you've fallen behind, I will let you know. So here's what's going to happen over basically spring break. Okay? First off, I'm going to grade and import a bunch of stuff from Runestone onto Canvas. Okay? So if you actually go and check your grader now, okay, so if you go and check Runestone now and go to your assignments, and you check the Chapter 1 exercises, you'll see that it should have already been graded. And that on a lot of them, there's a Score Me button, right? Once I grade it, the Score Me button disappears. But that Score Me button was never actually any use to you. All it did was tell you what your score was going to be when I ran the grader. If you did not finish it or finish an assignment and the Score Me button disappears, don't worry about it, okay? It will be graded next time I run the grader. So I generally try to not run the grader too often because the import process is annoying and it gets students worried. But if you see the Score Me button disappear on some of the assignments, don't worry about it. It's just that just means the grader has finally been run on that one. Okay. Hopefully I can actually do this tonight so I can go into more detail about it on Thursday. And the other thing about early alerts means that if that demoed assignments that have yet to be demoed, I'll be putting in zeros for them. But that does not mean that it's a 0 forever. It just means it's a 0 until you demo it. Got it? Right? So if you haven't demoed stuff yet, please, demo it to me so you don't get scared by having a 0. Again, the reason I have to put it in is because I have to figure out what your actual grade is, and I can't do that with missing grades. I have to put in zeros. So I'll be putting in grades for everything through Lab 4 and 5. So, okay. So, all right. Trust me, on how I do this, it makes sense with regards to that. So, okay. Let's talk about let's go over the assignment that I gave you, okay? First off, as a result of me doing a lot of this in class, I'm going to go over the easy parts in class, okay? I'm going to go over the easy parts in class. Let's see. I'm going to go ahead and say the hard is worth 5 extra credit points each. So if you decide to go on the harder path, you can get some extra credit for this, because I'm going to do a decent portion of the easy path today. Okay. These are taken from CS50X, and they will have actually a tutorial in a completely different language, which is C, not a completely different spoken language, but they program it in C. But you'll see how this works out. All right, so this one is Mario less comfortable. So if you've played Super Mario at any point, this original Super Mario Brothers game, if you haven't, it's worthwhile. It's a lot of fun. Towards the end of World 1-1, which is the first level, right before you get to the flagpole, you have the staircase of pyramids that you've got to go up. Right? Everybody see this? So our goal is very simple. We're going to recreate that pyramid. We're going to use text, and we're going to use these hash marks for the bricks. So we'll write a program called Mario, and then what the idea here is we're going to let the user decide how big the pyramid is going to be. Okay? So and what's going to do is it's going to ask them, hey, give me a number between 1 and 8. And then if you give them an 8, the program might be like this. And then the 4, it would look like this. And 2, it would look like this. 1, it doesn't look like this. However, this is the trick here, why this is going to make it different, which is if the user doesn't put in a good number, okay, then what are we going to do? We're going to just simply tell them to keep doing it until they give me a valid number, okay? So notice over here, we got a bunch of inputs, and we just simply put in 4, and we got that. So while we've learned how to do this, which is we're going to use a for loop to do that, right? We use some kind of for loop, or maybe we use replication as well to do this. This is new. This is the new thing, but it's not hard. If you know if statements, you're going to have a great time with this. So that uses what we call a while loop. And a while loop is an indeterminate loop. Indeterminate in this case means we don't know how long it's going to go for. For loops, we know how exactly long they're going to go for. Okay? Here, though, we don't know how long a while loop will go for. Okay? So let me give you a basic example, okay? Okay, so desktop and while loops. Okay, so what we'll do is I will say, hey, let's go with a couple of classic examples first. Int, no, not int. I'm not in Java. I teach Java in the other class. So I is equal to 0, while. So if I is less than 10, we'll go ahead and print I. Right? Everybody's kind of seen this code before with if statements or something like it. We have a number. If it's less, and we're saying if the number is less than 10, print that number out. Okay. Now, a while loop goes until it's no longer true. In this case, it's going to go on forever. Everybody can see that, right? I is equal to 0. While I is less than 10, print I. Well, as long as that's true, we're going to keep doing that. There's no way for me to change this. I've written an infinite loop. The program will go on forever until I hit Control-C or Command-C to interrupt it. Now, but the point of me doing that was to kind of show you one thing, how easy it was to go from an if statement to a while statement. You just change the if into a while. It uses the same Booleans, it uses the same logic. The only thing is that it's, instead of being a one-time thing, it's a multiple-time thing. So we can replicate some functionality of for loops using a while loop. While I is less than 10, print out I. I plus equals 1. In a lot of languages, you get both the for loop and the while loop. But in theory, you only ever need one. They both are loops. You can program one to do the task of the other. But having access to both is very useful because it's a lot easier to do some tasks in one loop versus another. In the case of a while loop, it's a lot easier to do. This is a lot harder for this task as opposed to a for loop, which might do the same thing. For I in range 0 to 10, right? Print I. I feel like that's a lot. The bottom one's a lot easier, right? So, what's the point of a while loop? The while loop is when we want to do something indeterminate. So let's go ahead and say, and a lot of times that means we're going to use the user input with it. Input. Let's go and write, input. Please enter a number, or rather, please say hello. Let's go ahead and do that. Okay, and we'll say greeting. Okay, please say hello. While greeting is not equal to hello, sorry, not equal to the string hello, print you didn't say hello. And this is the key for making while loops work properly, by the way, which is to do this, which is to say, if the user puts in something wrong, for a while loop, if you don't want it to run forever, you have to be able to change this. So we do kind of the same thing that we did earlier, which is greeting is equal to input, please say hello. So print greeting to you too. All right. So if I run this, the I is unnecessary here. It was just left over from the code I just overwrote. So please say hello. I'm going to say foo. You didn't say hello. Please say hello. Apple. You didn't say hello. Hello. Hello to you too. All right, so let's go ahead and clean this up. Please say hello. /T over here to add in a tab to make it a bit easier for us to look at. A bit easier on the eyes to look at. Because otherwise it just looks like one jumbled mess. So please say hello. Hello. There, that seems a bit easier. Or, as I prefer to do a lot of the times, just a complete new line. That's so much cleaner. Okay. Hello. So, first off, it says please say hello, and if I follow the direction over here, so I put in input, please say hello. We put in hello in here, so greeting got set equal to hello. While hello is not equal to hello. Well, hello is equal to hello. Make sense, everybody? Okay, so when I did this run through right here, what I did is I said, please say hello, and I put in hello. So greeting got set equal to hello. Yeah. Follow me so far? Yeah. While hello is not equal to hello. Well, hello is equal to hello, so this is false, right? It's saying while greeting is different from hello. That's another way to read the not equal. So while the greeting is different than hello, then do this. But they were different, so we just don't do it. Okay. So we just kind of skip it like we would skip an if statement. Yeah. Basically, the same rules apply for if statement as they do here. However, if I do something like this and I say HE, LLO, and I say apple, right, it's going to keep going no matter what. It's also remember, this comparison is also case sensitive. So if I say hello and I, spell it with weird caps and stuff like that, it's also going to give me issues. Didn't realize that was all the way over there. Okay. So it's only going to stop when I enter in hello. So when I entered in hello, I got the greeting over here. Well, greeting is not equal to hello. Well, it was now equal to hello. So I say greeting to you too. Okay. So another kind of way we can do this is we can do running sums with this. And then this is the last thing I think we'll need to do before we can get started on the homework. Right? Let's go with print. Please enter the numbers you want to add, right? Please enter the numbers you want to add. So here what I'm going to do is I'm going to write a program. I'm going to write a little script that tells me to enter a bunch of numbers, and when I'm done entering them, I'm going to add them all. I'm going to print out what their sum is. Okay? So this is not something you'd probably ever need to write on an exam. This is just kind of an example of this. So I'm going to say our number is equal to, I'm going to add in a number direction, because how do we know when to stop? I'll go ahead and say, please add the numbers you want to add. Print. Okay, and then enter -1 to stop. Well, so number, let's go with number is equal to -2, total is equal to, no, number is equal to 0. No need to confuse it. Well, total is equal to, so we're going to have our number, which is going to be our input, our total, which is equal to 0. And here what we're going to do in this case is that we could do an input right here, but I'm just going to do this. I'm going to do the input on the outside, on the inside of the while loop. While, let's see, while number is not equal to, let's go with numbers less than 0. Enter negative number to stop. Make it easier. Well, so enter a negative number to stop. So while the number is greater than or equal to 0, we will keep doing this loop. So what we'll do is we'll say number is equal to int, and oh yeah, I'm going to need to introduce some errors into this, some logical errors, but we'll see. So this will get rewritten a few times. Number is equal to int input number right, makes sense there. So we ask the user to enter the number there, and then number, and then total plus equals number. Print total once we're done, right? So how does this work? We run it. Please enter please enter the numbers you want to add. Enter a negative number to stop. Number. So number is 0. So while the number is greater or equal to 0, number, we ask for the number and then we're going to add it. Okay? So let's go ahead and add 5 and 5, and I'll put in -1 to stop. It'll tell me 9. Well, that's obviously wrong. 5 and 5 is 10. What happened here is I kind of mixed up the logic. which is that I've got a number, I've got my total. Well, number is greater than or equal to 0. Great. Then I'm going to ask for the number, and then I'm going to add it, even if it's negative. So there's a couple ways to fix this. Oddly enough, reversing it and adding the number before we even ask for an input solves that problem. Because what we'll do is we'll add 0 first, and then we'll ask for the number. And if it's a valid number, we'll go ahead and ask them. Make sense to everybody? Another thing we could do is another thing we can do, which is considered kind of not great, but I figure I might as well show you. While true, this is a forever running loop, right? While true, it's never going to stop. So here we go. I'll say I've got my number over here. I've got what I've written over here before. Int number is equal to int. Input this. If number is greater than if number is less than 0, break. Else break is yeah, I heard. What does that mean? Break is fairly straightforward in its meaning. So 5, and then if I put in -1, break merely it does exactly what it says on the tin. It breaks the loop. So what it does is that it says if you're in a loop, it's gonna break out of the loop. It's gonna stop it. Just terminates the loop prematurely. You want to try to avoid using break because if you've got nested loops, that sometimes gets confusing as to what loop you're breaking out of. You're breaking out of the one you're currently in, the innermost one that you're in. But this works just fine here. And again, if you're writing something on an exam and you can't figure out a way to do it except with a break, I'm going to take that answer as long as it's right. Again, there's nothing wrong with doing a break statement. It's just, as you saw, there's a way that was a bit more elegant to do that. Also, writing a while true especially is kind of considered really harmful. You don't want to do that because you're saying, I'm writing something that's never going to end. My preference for writing while loops is to do something like this. Done is equal to false. While not done. It's very similar, but it just reads better, I feel. While not done, number is equal to input. And then, so we get our number here. And instead of, if the number is less than 0, rather than saying, oh, we're going to stop, we're going to break out of the loop, we're just going to set done is equal to true. And that way, if there's some other code here if there was some other code here, if there was some other code there, that code would still run and then the loop would finish up, it'd get to the end, then we'd get back to the top. Oh, we are done, so we'll stop now. So by doing it like this, it allows the rest of the loop to run. Breaking literally just breaks it where you are. It doesn't continue, it just stops where it is. Make sense? So use whatever one gives you the proper control over this. So now we can just simply add these numbers, but now we've got ways of adding these numbers together. 80, 81, 82, 50, right? And it's just going to take as many numbers as I want to put in until I put in a negative, and then it will add them, and then it's going to tell me what the added total is. That looks about right. I wouldn't know. I have the computer to do the math for me. So, our first problem is broken. So our first problem in Mario, let's go ahead and open a new file. And I'll save it because this is going to be the easy Mario that I'm doing. The hard version is going to follow the same way. It just uses 2 pyramids, I believe. So in this case, what we're going to do, and again, the reason we're doing this in class is because the due date is Friday. I really don't want to change that, but then I also might but then I'd be giving you work over spring break, and I know exactly how much you're going to work, which is not at all until you get back on Saturday, and then you're going to panic and go like, oh, right, I have all that work I need to do. It's what I would do. It's totally what I would do. I always say I'm going to do these stuff over spring break, and it never gets done. So, so let's go ahead and get this done before spring break then, okay? So with Mario, the first step with the Mario program is that we need to ask the user to input a height, okay? A valid height. A valid height for us is between 1 and 8. Got it? So we have to ask the user for a number between 1 and 8. If they don't give us a number between 1 and 8, then we need to ask them again. Here it just simply says height and doesn't say anything else. Now, there is one kind of unspoken question here, which is what if I do something like this, which is, okay, so height is equal to int, please enter the height. Okay. I could do that. Okay, please enter the height. Oh, int input. Actually, I'll just do input right now. Okay, please enter the height. Height is equal to this. All right, and I'll expect this person to put in maybe 4. You know, what about, and maybe I'll put in -7. I'm going to have to handle that. But what if the person who's doing this enters in, oh, the height? It's going to be 8. Do I have to worry about that? No, not for this program. That's this kind of input is not. There's ways to guard against it, that are fairly straightforward, but that requires you to learn about catching exceptions, and I don't want to introduce more complexity into this. Assume that the user is going to enter in a number, and a number in a valid format, not a invalid format. Assume basically that putting the int statement around it is not going to crash. Okay. So here we're going to ask the user for their input. Okay. And the while statement is to make sure that we keep doing, that this is going to be true. So ensure, okay, so ensure so I'm going to give us our outline. So we've got the height from the user. Ensure the height is valid. This is done by re-asking if the height is not valid. So that's going to have a while, something in there, and then ask again over here. So that's a fill in the blank for you, which you're about to do. So you will get the answer there, but I want you to work on a bit, and then do the Mario stairs, which is a part of this you're already familiar with. Okay. So take about 5 minutes to work or a few minutes to kind of just make sure that your input, you get this while loop working. It shouldn't, if you're getting it, it shouldn't take you that long. But again, so while the input is not a valid. Valid is between 1 and 8 inclusive. there's multiple ways to do this, by the way. The Boolean statement for the dots, there's a ton of different ways to do that. You can say, well, it's not valid, or you can say, well, it's outside of the valid range. There's a lot of different ways. So let's go over a couple different ways to do this. So basically what we want to do is we want to ensure the height is valid. Meaning that we want to make sure that when we're beyond this while loop, if I have a print statement over here, then that print statement is going to print out a number between 1 and 8. Okay, only between 1 and 8. Make sense? Okay. So in order to do that, well, there's a couple different ways. Well, first off is the wrong right way. In other words, the way that is totally going to be, there's a couple ways that if you put it on the test, I'd go, yeah, I guess, but I'm not happy that you did that. So that includes if while height is not equal to 1 or height, height is not equal to 1 and height is not equal to 2. You see where I'm going with this, right? That technically would work, but that's not what we want to do. So we'll leave this up here for a second, okay, to just test it. And then what we're going to do is that once we're in the while loop is that we will just simply copy this, Control C or Command C, right? Notice I never right click to do any of that. I just always use the keyboard command. It's a lot quicker. So we'll just simply run this. So I'm going to say 7, 8, -1. Once I hit 1, exits there. So it would work for me putting and 5 and 6. Technically, you could also do something like this, which is if while height is not, well, actually, I'll move on. Actually, I'll leave that for last. But that would technically work. It just takes a lot more effort. What we could do is something like while height is greater than 8 or height is less than 0, right? While one of those things are true, while it's bigger than, well, it's less than 1, rather, right? While it's greater than 8 or less than 1, well, one of those things are true, right? See, that just passes right through. That's correct. Please enter a height, 100, -200, -1, -2. This making sense for everybody? While the height is greater than 8, or the height is is less than 1. 100 was greater than 8, so that was true, so the whole thing was true. -200 was less than 1, right? -200, it's negative, so it's less than 0, so it's less than 1. -1, -2 are both less than 1, and 5. So we're good. So there's other ways to do this one as well. If you're like me, I love the fact that Python allows us to write stuff like this. Height is less than or equal to 8. You can do a compound inequality, I think it's called. You can basically make an inequality like this. So this is the valid range, right? Sometimes it's easier to write the valid range. So while it's valid, keep asking for the height. That's not what we want. We want the opposite of that. And to do the opposite of that, we say while not. Make sense? While it's not that. So while it's not in the valid range. And I think this should work. 70, 71, -5, -4, -5, and 7, and that works. And the important thing here is to understand why we're using a while statement as opposed to using an if statement. If it was an if statement, and I did -3, -2, it would just simply take my second number. It would only work once, right? That's the difference between an if and a while. An if statement will move on, whereas a while statement will loop back. That's why it's a while loop, not a while statement. Make sense? So we want a while loop over here, in case it wasn't clear. Okay? So to do that, right? So now to do the Mario stairs, right? That part is fairly straightforward. That part is, I think, fairly straightforward at this point. I will come back to that because I want to move on to the next part, which is also this part is the part I know that students struggle with the most on this next part. So, yeah, we're going to go ahead. But in case we don't get to it, I'm going to leave this part to you, because this is very straightforward. You write, you're going to do a for loop to print out the stairs. So now, next one, okay, if you want more of a challenge, by the way, you do the stairs like this instead. It's the same concept. So cash and credit are completely different problems. So we're going to do cash, which is a very, very, very common computer science problem for beginners, which is given a number of coins, given a number of cents, give me the most efficient way of giving change for that. Or not necessarily the most efficient way, but give me the number of coins that would be the most efficient way. So in the US, we have, for coins, we have the 1 cent, the 5 cent, the 10 cent, and the 25 cent. I mean, there's a 50 cent and a dollar coin as well, but we're going to ignore them because they're not nearly as common, right? They're not nearly as common. And if you're still working with cash, then you need to hand out change, right? You hand out your bills and then you got to hand out change. The idea here, though, is that you probably don't want to hand out, like, if the customer has been, if the change that you have to hand back to a customer is $1.50, you don't want to hand them back $1 and then 5 dimes, or $1 and then 10 nickels, or you don't want them to hand them back $1, a quarter, and 5 nickels. You want to hand them back $1 and 2 quarters. That's the most efficient way, right? The least amount of coins given back, right? So you hand them back. So what our program will say is that given 50 cents, it will hand back 2 coins. Right? That's what our program will do. So basically, the idea here is that now what we're going to be doing here is implementing your first of something that you're probably not going to hear again until 3223 if you take that class, but is a very important concept. It's called a greedy algorithm. Now, a greedy algorithm is an algorithm where making the most efficient choice now is the most efficient move overall, right? So there's some places where if you take the most efficient choice now, that's actually the worst thing you can do, right? That's some problems like that, right? You won the battle, lose the war kind of thing, right? I'm sure you've heard that phrase, right? Then there's some algorithms where that's true, where basically choosing like the best the best choice now does not necessarily guarantee the best choice later. Suppose you need, like, here's an example. Suppose you're traveling. You need to go from and you're making 2 trips back to back. You're flying from Philly, and they're going to go to LA. Okay, you're going to fly from Philly to LA, and then your second trip is to Arizona. And you only need to be into, and let's say that it doesn't matter which order you do those in, right? So if you go from Philly to LA, and then you go to Arizona, that might be one price. But if you go from Philly to Arizona to like a third airport and then to LA, that might be actually ridiculously cheaper because the airline flight is weird. Make sense? Right? Choosing just the most apparent choice, okay, I want to go to California first or Arizona first. I'm going to go that way. I'm going to go whatever cheapest first. It may not be the cheapest price overall. There might be something in the middle that's much cheaper. So now greedy algorithm, it says making the best choice now is always the best choice. There's a number of good greedy algorithms that get covered later, like Kruskal's and Prim's algorithms, which are graph theory algorithms, but those again come much later. This one's fairly straightforward. It's a good one, which is given the amount of change. So yeah, here's the National Institute Standard definition. It always takes the best or immediate or local solution when finding an answer. Greedy algorithms find the overall optimal solution, but may find the less than optimal solutions for some instances of other problems. So a greedy algorithm can be used on that kind of problem, where basically choosing the best solution now might not result in the best solution overall. But there are some problems that like this one that can be completely solved by greedy algorithms. Okay. So let's go to the problem definition. Suppose a cashier owes us some change, and we've got dimes, quarters, nickels, and pennies. The problem that we're solving is decide which coins and how many of each to hand back to the customer. Think of a greedy cashier as the one who wants to take the biggest pride of the problem possible when they take out the drawer. So for instance, if we owe them 41 cents, the best thing to do first is to give back a quarter, right? Subtract 25 from the total. That's the biggest amount we can subtract from that. That gives us 16 cents remaining. Now the next biggest thing we can take out of that is a dime. So we remove a dime, and now we have 6 cents remaining. Then we take in a nickel from the 6 cents remaining, and then we take out a penny, and so we've given back 4 coins: a quarter, a dime, a nickel, and a penny. Make sense to everybody? It's local for American currency as well as EU currency, but some currencies actually that may not be true for. It actually depends on the denominations of the currency. All right. So as long as the cashier has enough, which you will, the largest, the smallest will yield us the smallest one. So what we're going to do is write a program called cash.py. It's going to first ask how much change is owed, and then print the number of coins that with which that change can be made. Okay? So we're going to get input from the user. Okay, we're going to get the user's input and output our question. So assume only, right, we're going to assume those. We'll ask you to assume the user will be inputting a float, so you can handle dollars and cents, but without the dollar sign. So if some customers owned $9.75, they're going to plug in 9.75, not $sign 97.75. Make sense? But they're going to plug in the amount of money they owe. Okay? What you do need to do with this is that we are going to create a function that detects whether that is a valid string or not. Whether it's whether. So last time, with the last problem we just went over, right, with Mario, I said just assume they're going to put in anything. Sorry, they're going to behave well, right? This time we're going to assume they're not behaving well, that they can put in anything. We want to make sure that the string is a float or not. Now, I personally, and I believe I added this. I think I added this. It might not have. It might have already been there. But I'm going to call. What you want to do is write a function that will validate the input. I call mine is float. It's going to take it in a string, and we're going to return whether or not that string is a floating point number. In other words, does it match the format of this? Does it match the format of some amount of number time, dot dot? Does it match this format, right? Okay. If it is, and so there's a few different ways you can implement this idea I put down, which I'll go over. Count the number of decimal points, and make sure both sides are numbers. All right. So you don't need to check whether a user's float is too big. And make sure that it is a positive number, as we did similar to, don't give back negative 75 cents. Right? Make sense? Okay, so the output looks like this. Change owed 41 cents for. Change owed negative 41, foo, 0.41, 4. So first thing we're going to do is work on that isFloat function. Okay, so save. So new file, cache.py. Okay, isFloat. So we're going to write a function called def isFloat, which given a number tells us whether or not this is given some text, some string that's been plugged in to us. Given some string, determine whether or not it is a floating point number. Can we convert this to, in other words, can we throw this around it without causing an error? Make sense? Okay. So let's go ahead and figure out what makes a floating point number valid. Okay? So let's go ahead and write down first off some things that are valid floating point numbers. So what are some valid floating point numbers? Or could be converted into one. One could be converted into a floating point number. We're not worrying about negatives right now. Negatives will be handled somewhere else. We're just asking, is this a floating point number? That is a valid floating point number, right? 8.7, okay, and we can actually make this as big as we need to, right? So let's now write some non-valid floating point numbers. 8.72. Why isn't this valid? This is not a trick question. Why is this not valid?
It's considered a string.
Yeah, it's got a string in it. Specifically, what's the characters that are problematic? Because these are all strings. What's the problem with this one over, what's the issue between this one and this one specifically?
There's no numbers.
It's just letters. It's using invalid characters. These characters don't appear in strings, right? So that's a big difference, right? That's kind of is the difference between what is a valid floating point number and isn't a valid floating point number. Okay? So, like, what are the valid characters that we can put in a number? 6, 7, 8, 9, 0, period, negative, plus. Make sense? Okay, those are the valid characters. Technically, and yes, technically doing this is technically the unary operator, as it's called, the positive unary operator, is technically valid. It's just like you don't use that much, right? The positive unary operator, in other words, it turns a number positive, but numbers are already positive. You only really use it for something like this, but in which case, yeah, it's not really doing anything there, right? So, you know, we can ignore that for right now, but let's go ahead and see. So what we'll do is that we'll say is that I'm going to take this right over here and use it. So first what I'm going to do is when we're trying to determine true or false, I always find it to assume one thing and prove the other. Here, I think it's easier to try to prove that it's not a floating point number. So subject it to a few tests, and if it passes the tests, it is a floating point number. So we're going to assume it's true, but as soon as it fails a single test, right, it's not a floating point number. So that's why I've returned true at the bottom, because it's going to be, we're going to assume it's true. So here's our valid characters. I'll put them in a string. And first we want to make sure that all the character, so here's what we want to do. Check every car in valid cars. Sorry, not every car in text. If the car is invalid, return false. Else, there is no else. Just simply, if it's not valid, return false. Okay? That's actually a very common mistake that beginners have or in Intro to Python class where they feel like, okay, if it's invalid, return false, else return true. That you don't want to do that, as you'll see. So go ahead and try to program that. To check every character, what tool do we need for that? That's a for loop.
we have a border, so what you want to do is iterate over every character in text. Okay? No. For every letter in text. And then what you want to do is ask, okay, is this letter good? Oh, sorry, is this letter bad? How would I tell it's bad if it's not one of those? Now, one thing that will make the job easier is using the in statement. So like invalid characters. Because then you can check it, and that will ask, is something in one of these characters? We aren't going to use so this one we're iterating over something. So in this case we're not using the range. We don't need a range of numbers. We're going to iterate over the text itself. So for letter in text. So text in this case is what we're checking to see if it's a float. And what we want to do is that we want to check if it's a float, what we want to do is go over every character in it. In other words, we'll write a for loop. So for car in text, or for letter in text, or whatever, that's that first part. Check if the character is invalid. How do we know if it's invalid? Well, we know how to check if it's valid. Let's go ahead, or rather, let me see about how to check if it's valid first, and then I can say if it's not valid. Now, one way to do that, as we've seen, as I alluded to earlier, is I could say if car is equal to 1 or car is equal to 2, but that would take forever, right? And it'd have to be strings as well. So instead what we do here is a much quicker check. For car, if character in valid characters. If you haven't seen that yet, I think it's come up in the videos at this point, but the in statement makes this kind of check a lot easier. Make sense? So if this checks if it is a valid character. And we can use this to do the opposite. If character is not invalid characters. Make sense to everybody? Oh, that's the nice thing about Python. A lot of it can read very close to English. If for character in text, if that character is not invalid characters, then we return false. Now remember what I said about breaking earlier? About the break statement, how it breaks out of a loop? Returning works very similar for functions. When you have a return statement in a function, in other words, this will give back false, it stops the program at this location, because what a function needs to do a lot of the time is return something. And once it's returned something, it's done. So it stops there. So it doesn't continue on with any of the other checks. That makes sense to everybody? Okay. So now the other checks there are some other checks we can do that get progressively more pedantic. Okay? Right, so is there any way I can make something invalid with the valid characters like this? Oh, this one's valid, even though it's made up of the invalid characters, right? A plus and minus there should only be one of them, right? And also, if there is going to be a plus or minus in a floating point number, they should be over here, right? At the beginning, right? This is not a valid floating point number, right? That's two numbers. We want one number. That's not a valid floating point number. And furthermore, let's come up with some more nonsensical examples, and we're going to kind of work through them one at a time, but very quickly. So other nonsensical examples. Let's see, 9.1, right? That's not going to work. At most, we want only one decimal point, right? 141. Again, so let's go ahead and address this one first. We'll leave the positives and negatives out for a second. This one's fairly straightforward. You can only have one decimal point in a floating point number, right? Make sense? Only one floating point in a decimal point. Sorry, only one floating point in a decimal number, right? So, we're going to use strings to our advantage. If text.count, remember what count does for strings? Counts the number of things in a string, the number of times something appears in a string. If that is greater than 1, it's not valid, right? Makes sense? If there was more than one decimal point in a number, like this, like this one over here, but also like this one, 98.87, right? 0.76. That's an invalid one, right? Makes sense? That's not a valid decimal, that's not a valid floating point number. Only one decimal point allowed, at most. You can, I'm fine with having none. We can convert that into a floating point number, no problem, right? One, for instance, 1 would just simply get converted to 1.0. So, no problems. So, the only problem occurs if there's more than one. Return false. Okay. And the same applies for the positive signs and the negative signs. So I'll just simply do an or here. So if we have more than one negative sign or more than one positive sign, right? Can only have one of those. Those are rare. Make sense, though? And now the last part, which is making sure that this 3.5 negative sign is detected as invalid, as well as 4 plus 5 is detected as invalid. And this basically comes down to one thing, which is that the plus sign and the minus sign are in the wrong place, right? Okay. Yep. I realized I messed up with my logic here just slightly, but it's a real edge case, so we'll go over that last. Okay. So I want to keep focusing on this. So the minus sign and the plus sign, right? They have to be at the beginning. So we say, so we're gonna say if text.count, the plus sign is greater than, is equal to 1, right? If it has 1, right? Or we can even say, or we can even rewrite it like this: if plus in, because here we've established there's not going to be more than one, right? So I can shorten it by saying if plus is in this, right? And And then rather than making a separate if statement, I'll say and. So if it has a plus symbol, and the first character, text 0, is not equal to plus, return false. So what's going on there? So what I've done here is I've asked, hey, does plus sign appear in text at all? We could also simply say this, which is, simply say this if it has 1, right? So if we have a plus sign, and the beginning is not a plus sign, that means the plus sign's in the wrong place, right? Similarly, if we have a negative sign and the negative sign is in the wrong place, right? If it's not at the beginning, it's at the wrong place. Make sense? Return false. All right, I think I've covered everything except for the thing that I totally forgot, which is, actually this one will catch it. Because my issue with my logic that I thought of, but actually these two statements separated catch it, was what if it has both a plus and a minus sign? It can't have both a plus and minus sign, and that loop doesn't catch that that's wrong, right? This if statement doesn't catch that this is wrong, right? What I should be asking I should be asking that, technically, or text count of minus plus text count of plus is greater than 1, right? But it would actually turn out, funny thing is that sometimes bad logic actually turns out okay, and it can kind of hide, because these two statements, if I have a string that looks like this, right? If both the plus and the minus are in a string, only one of them can be at the beginning. So these two statements saved me from that error. Make sense? All right. So what we can do here is that we can actually run the. So one thing I love about idle is I can run this right here, and you're like, but that doesn't run anything. But it ran the defining part of it, so I can say is float, and I can say is apple afloat. False. Is 1 afloat? Yes. Or can it be turned into a float, rather? 1.0. True. What about 1.0256? Negative. True, that is a float. What about negative 7 plus 2? Or negative 1 plus 2? False, that's not a float. What about 3.7? False. Okay, so now we have a way of checking if the number is, so now we have a function here, that we can ask a user something like this. Place the following somewhere useful. Okay. Right. And add a prompt. So while, so now let's see, input, while text is not equal, while is float text, well, that's false, so we'll say while this is not a float, keep asking. Let's see what that looks like. Looks like it looks like it's doing nothing there, but it's waiting for me to type, I think. Yes, it is, waiting for me to type. So, apple, banana, 1.5, and then stops. Make sense? So, we asked for input. While that input was not a floating point number, we kept asking. And now it is a floating point number, so great. That means that we can throw a float statement around that. Okay, so what about for the rest of the program? Which I'll debate, we'll see what, if I'm doing that on Thursday or not. But what about the rest of the program? Let's see. So for the rest of the program, what you want to do is, for the rest of the program, what you want to do is figure out the minimum amount that is made. So how do you do that? How do you make sure that the minimum amount is made? That you get back the minimum amount of coins? Well, the first thing you want to do, the answer is you use a bunch of while loops. Not nested while loops, just while loops that are kind of next to each other. You ask yourself, you think about how you would do this if you were handing back change. Oh, I have to give back 75 cents. Okay, can I give back a quarter? Yes, I can. Okay, I have 50 cents left. Can I give back a quarter? Yes, I can. Add 1 to the amount of coins I've given back. So now I'm at 2 coins given back. I'm at 25 cents now. Can I give back a quarter? Yes, I can. I'm at 0, so I can't give back any more quarters. I've given back 3 coins so far. Now I check against the number of dimes. Can I make 0? Can I make change from using a dime of 0 cents? No. Same with nickels, same with pennies. Right? What about 76 cents, right? I'd subtract 25, add 1 to the total, 25, add 1 to the total, 25, add 1 to the total. So we're down to 1 cent, and we've made change with 3 coins. Can I use a dime to make change with 1 cent? No. Can I use a nickel to make change with 1 cent? No. Okay. Can I use a penny to make change for 1 cent? Yes, I can. Add 1 to the total, subtract 1 from the amount of coins remaining. So that's kind of the algorithm you need to use. But you're not using if statements here. You're going to be using while loops to do that. Okay. So while you can make change, subtract the value of that coin, add 1 to the total. All right.